When we introduced the protocols on the transport layer, we mentioned beside of TCP, there is another one, the UDP protocol. You remember this UDP protocol compared to the TCP protocol was very simple. So we have only one lecture video about this UDP protocol. Compared to TCP, which provides a reliable, connection-oriented transport service, and of course, this establishing such a connection, this guaranteeing reliability by this retransmission mechanisms, by this sliding window mechanism, by this load and congestion control. It's a lot of work to be done for running a TCP connection. So in a few cases, this is too much overhead for simply exchanging messages between two applications. And for that purpose, and also for other protocols that need a very fast transport, the UDP protocol, the User Datagram Protocol, was developed. This UDP protocol is an alternative protocol compared to the TCP protocol, and it's especially designed for sending very short message without of having to establish a connection, without of having all these features that make TCP a reliable service. So this UDP this UDP protocol is connectionless and it's unreliable. It cannot provide this service like TCP. In the moment I want to spare all this overhead, I has to come out without it. UDP, like TCP protocol, is located directly on IP, and UDP provides as a functionality just the so-called communication ports, the UDP ports, for linking the communication process with the application. The IP datagram takes care of sending datagrams, exchanging datagrams between two systems, between two network interfaces. But on the transport layer, we want to connect the communication with the application that want to use the communication protocols for exchanging messages. So what's needed is to have these endpoints, to define these endpoints of a communication, and this is exactly what the UDP protocol is doing. It assigns UDP ports to the communication. So for that reason, UDP is also sometimes called port multiplexing. UDP is used by different protocols on the application layer, which we have to discuss next week. And it is used by such protocols that only needs a very limited and simple query response interaction. For example, trivial FTP, or domain name service, or NTP protocol, RPC protocol, LDAP protocol. You see, these are the reserved port numbers for these services. So UDP receives data from an application via their ports, and then forwards this information encapsulated in an UDP datagram, encapsulated in an IP. The UDP datagram is encapsulated in an IP datagram, and then it is sent to the computer the partner application is running on. So the port numbers established for TCP and UDP, they can differ. These are different protocols. However, in many cases, particularly if both protocols can make use of this port number, they need to be the same. The structure of an UDP package, therefore, is very simple compared to the TCP segment. At the header of the TCP segment, here we have only the four header fields: the UDP source port, the UDP destination port, the UDP datagram length, and the checksum, and then the UDP payload comes. So the source port, of course, is a port number on sender side. The destination port is a port number on the receiver side. The port number that's used by the both application that want to communicate via the internet. In the length field, there is a 16-bit field. There is a length of the UDP data in bytes described. The minimum here is an 8-byte, and this is exactly the length of the header. And then the last field was a checksum, 16 bits long again, and here via UDP header, UDP payload, and same with TCP, this pseudo header with the algorithm used in IP. This is used to compute the checksum. The calculation in case of UDP is optional. You remember UDP is a very fast transport service, unreliable connection that's only for exchanging data, very short and simple data, to support protocols on the application layer to allow applications to interact in a very simple way using the IP datagram service.